This part is okay. So 9.7 is Taylor polynomials and approximation. Okay. Right, so in this section, we're going to look at the Taylor polynomials and the approximation to the functions. So how polynomial functions can be used to approximate for other elementary functions. For example, if we have fx equals, if we have fx equals y equals e to power x, then e is a constant. Everyone knows that it's 2.1. Okay, as a constant number. And if we look at the function, it's going to be like this. This is the y equals e to power x. Okay, and first degree of polynomial at 0. Okay, so first degree polynomial at x equals 0. So basically first degree, it means the function is P1 polynomial first degree P1 x equals a0 plus a1x. Okay, it means I will use a first degree polynomial. It will use a linear function to approach the value at x equals 0. You can see the function, the exponential function is increasing function like this. Now I will use a linear function to approximate at 0.01. So if you plug 0 into the function, you get fx equals f0 equals 1, right? So 0, 1. And this point is 0, 1. So I will use a linear function to approximate the whole function. Look, we can see. So first you get f0 equals 1. You plug into the function. So p0, you got p0 equals a0 plus a1 times 0 is 0. So is a0 plus 0 equals 1. You got a0 equals 1. Does that make sense, everyone? Okay. So the next one, if we take the derivative, f derivative of 0 equals, if I take the derivative, the original function give me what? Is p prime of 0. If I take the derivative, then the original function, if you take the first derivative, is still, for the function itself, f first derivative is e to power x. For the polynomial function is the derivative of a0 equals 0. Derivative of a1x is just the a1. So then we plug it in again. I got pf prime of 0 equals 1 again. And then because here p1 prime of 0 equals a1 equals 1. Okay, so I solved a0 and a1. So a1 is given, a0 is given. Now, okay, so now I find the function is p1 x equals, I got p1 x equals x plus 1. Okay, well, if you say, what if I continue? Well, f second derivative is 1, continue, but the second, for the other linear function, the second derivative equals 0, so it doesn't work anymore. Okay, so this will not work anymore. Then I got the first linear approximation is p1 x equals 1 plus x. Okay, if I draw the picture here, you can see, if I draw the picture, this is y equals 1 plus x, or p1x, the first degree of approximation. You can look at these two functions. This is the exponential function. This is the first degree polynomial function 1 plus x, if I approximate it, they have exactly the same value at this point, 0, 1. However, close to this point, they're still close, pretty close. But further away, the error is pretty big. Okay. What if I do a little bit more? What if I continue? This is the first degree of approximation, right? It's like this. What if I continue a little bit more? Let's use the second degree. See what happened. Okay. So second degree is the first degree. Okay. Now, what if I use the second degree? Second degree polynomial is going to be p2x equals b0 plus b1x. Well, second degree of for sure you're going to have b2x squared, right? Okay. So, in the same way, I can find out b0, b1, b2. Okay. And if you use this 0 is the same, since I previously find out f prime of 0, if you do p2 0 equals f2 f0, and fx is still the same, e to power x. If you have p2 0 equals f0, you got b0 equals 1. If p2 1 equals f1, not 1, p prime of 0. P prime of 0 equals f prime of 0, you got b1 equals 1. This is the previous thing, right? So now I want you to continue to find out p2 second derivative of 0 equals f second derivative of 0. So what do you got? I'll give you 1 minute to solve this. So now I would like you to try p2 0 equals f2 prime f second derivative. Look at the second derivative, then solve the b2. Okay. So what is the second derivative of f? First derivative is itself ex. Second derivative is ex again. Because you know that fx equals e to power x. Then first derivative is e to power x. Second derivative is e to power x. Third derivative is e to power x. It never changes. It's always itself. So f second derivative 0 equals e to power 0 equals 1, right? Then what about p2, the polynomial function second derivative? Polynomial function first derivative is b1 is, if you take the second derivative, this goes to 0, this goes to 0, you only have this degree remain. So it's 2b, 2b2, okay? Because p2 first derivative equals derivative of b0 is 0, derivative of b1x is b1, derivative of b2x is plus 2b2x. And you continue to take the derivative again, you got p2, the second derivative is 2 times b2. Then since these two are equal, so you get p2, you solve for b2 equals a half. Because they are equal each other, right? Since they are equal, 2 times b2 equals 1, so b2 equals 1/2. Now I got my second polynomial function equals 1 plus x plus 1/2 of x squared. Now if I graph this picture again, if I graph the picture, it's going to be like this, This is the y equals e to power x. Now the other one, I believe it's closer. It's better than the previous linear approximation. It's going to be better. wait. It's much better if I have something to. I'll use the online graphing calculator and show you. Okay, so the other one is much better. It's a little bit better again than just a linear function. So suppose this is y equals 1 plus x plus half of x squared. So it's much better. They're closer. Not exactly the same, but better than the first linear equation. Let's continue, see what happened. Okay. So how about P3, third polynomial, third degree polynomial, P3x equals C0 plus C1x plus C2x squared plus C3x cubed, right? Alright. So I'll give it 2 minutes, see if you can find out the P3x by itself. Okay, basically what that means, find this the third degree of polynomial. It means they are exactly the same at that point. First derivative at that point is the same, second derivative at this point is the same, third derivative at this point is the same. Okay, so what do? I do the same thing because I'm using the polynomial to approximate y equals, to approximate fx equals e to power x. I'm using this function to approximate it. So the best thing is going to be they are equal at that point. First derivative equal, second derivative equal, third derivative equal, fourth derivative equal, fifth derivative equal. All the derivatives are equal, then they are exactly the same thing, right? That's the best scenario I can have. But if you require more accuracy, then you have more power, right? Need more the degree is going to be higher. So now I look at the third degree. I can at least satisfy the value at that point. First derivative, second derivative, third derivative. They're all exactly the same. The polynomial function and the original function are exactly the same as these four conditions. So first you can set up f0 equals p0. Then you plug 0 in, 0, 0, 0. So c0 equals 1. because f of 0 is always f0 is 1, prime of 0 is 1, second derivative of 0 is 1, third derivative of 0 is 1, because it never changes. Because it's e to the power x, right? E to the power x never changes, so it's always 1. Now, I do set first derivative equals p3 prime of 0, then I solve c1 equals what? Can anyone tell me what the c1 is? What did you got for c1? What you got for C1? 1. Very good. How do you find a C1? Plug it in. You already know f prime of 0 is 1. That's for sure. Plug 0 into the first derivative. First derivative of P3. First derivative is what? What's the first derivative? First derivative of P3 is. First derivative is 0 plus C1 plus C2, 2C2x plus 3C3x squared. Plug 0 into it. Plug 0 into it is 0 plus C1 plus 0 plus 0 equals 1. So C1 equals 1, right? Alright, so in the same way you can solve C2. Second derivative. Let's take the second derivative. Second derivative of the x equals derivative of 0 is 0, derivative of c1 is 0, derivative of 2c2x is 2c2. Derivative, second derivative of c3 is going to be 6c3x. Now you plug derivative into that. So plug 0 in. So plug 0 in, 0 plus 0 plus 2c2 plus 0 equals 1. Because this always equals 1 here. Right? Plug in is 0, is 1. So you got c2 equals 1/2. In the same way, you can solve c3. Can anyone tell me what you got for c3? 1/6. Okay, how did you get it for 1/6?
I took another derivative.
Yeah. Yeah, you take another derivative. Is very good. Take another derivative. You got a 6c3, and this equals 1 because you see that is always equals 1. You got a c3 equals 1/6. Now my polynomial is given. Is 1 plus x plus half of x plus 1/6x. Sorry, square cube, right? Okay. I will draw all the picture together. We will do one more. So the last one, I want to try one more P4x to approximate. So let's say D0 plus D1x plus D2x squared plus D3x cubed plus D4x power 4. I would like you to find out D0, D1, D2, D3, D4. See if you can finish that. You actually only have to find a D4 because the previous one would be exactly very much the same after you say that. Okay. So can you find out this P4? So basically I have P4x equals, okay, f at 0 point, right? So f4 at 0 equals P4 0. You can solve for D0. And f4 0 prime equals P4 prime 0. You can solve for D1. Second derivative 0 equals P4 second derivative equals D2. Third derivative equals P4 third derivative equals D3. And fourth derivative 0 equals P4 fourth derivative at 0 equals d4. You can find d4. Okay. One equation will give you one variable. Will give you one thing known. If I continue p5, you get, if you have a d5, it's going to be have the another derivative. Okay. You just need to plug in, because f40 equals 1. They all equals 1 because the function, f function is e to power x. Right? F function is e to power x. So f40. Why do I have so many 4? There's no 4 here. Just have 0. Okay, f of 0 equals 1, f prime of 0 equals 1, f this equals 1, because 1 equals 1. Because it's just e to power x. It never changes. It's e to 0. And the other one, you just need to plug in. Plug 0 into itself, plug 0 into the first derivative, plug 0 into the second derivative, plus 0 into the third derivative, plus 0 into the fourth derivative. That makes sense, right? Okay, so now I would like a student to tell me what your answer is. So I want to call a student here. Okay, Taylor, could you please tell me what is D0?
I wasn't sure how to go about doing this problem.
Okay, I'll do D0 and you can work on with me together. Okay, so what I mean, to do that, you match up these two values that are exactly the same value, because I'm using the polynomial function to approximate the exponential function. I'm using to approximate it. The best approximation is they are all exactly the same. If the function value, derivative value, all things are exactly the same value. But now I need to find out the polynomial function. First, the function value at this point, we check if it's the same. We make sure they're the same. So I plug 0 into the polynomial function. Taylor, could you please do with me? If I plug the 0 into the function, what I got? P40, what is that?
Would that just be 1?
Oh, it's a D0, right? I plug it in. D0, plug, what is that? D1 times what?
2D2, or I'm not too sure.
Because I'm saying that x equals 0, plug 0 into x. So all x will be 0. So D1, 0, right? Plug D2 times 0 square, plus D3 times 0 cube, plus D4 times 0 fourth. Does that make sense, Taylor?
Yep.
Okay, basically plug 0 into the function, see what you got. You got just equals D0. Because the function value equals 1, so D0 equals 1. Does that make sense, Taylor?
Yep.
Okay, can you help me find out D1?
It would just be 1 again.
So what do I do with the polynomial function?
We would take the first derivative and then plug the 0 in for x.
Yes, I take the first derivative of that. You got what? What's the first derivative of this function? What's the first derivative of D0?
I'm not sure, would that just be 1 or
The derivative constant.
0?
0. Very good. What's the derivative of D1x?
1.
What's the derivative of 3x?
3.
Yeah, just a 3. But the derivative of D1x is the D1. Okay. What's the derivative of D2x squared?
2D2.
2D2x. What's the derivative of D3x cubed?
3D3x squared.
3D3x squared. What's the derivative of D4x4?
4D4x cubed.
4D4x cubed. Perfect. So now I plug 0 in. What I got? 0 keep it, d1 keep it. What about this one?
Looks like it's just going to be the d1 that we'll have left because all the other values will just go right to 0.
That's perfect. So this one is equals what?
1.
Yeah, it equals, I want this one equals f prime of 0 because the function value equals each other. First derivative, they have to be equal. So f prime of 0 equals 1. Then I can solve d1 equals 1, right? So can you help me continue with the d2? So how to find d2?
We're just going to take the second derivative of the original function, or it'll be just the derivative of the derivative that we just previously found.
Yes. What's the second derivative of p4x?
That'll be 0 plus 2 plus 6x dx, or d3x.
So the derivative of this is 0 is 0. Derivative of d1 is 0. Derivative of 2d2x is what?
Would that just be 2d2 or?
2d2. Very good. What's the derivative of 3d3x squared?
6d3x.
Very good.
And then plus 12d4x squared.
Very good. Okay. So what I need to do next?
When we plug in 0 to throughout the equation, we're just going to have 2d2 remaining.
Yes, equals 1. So I can solve d2 equals 1/2. Can you continue help me find out d3?
D3 is going to be 2 plus 6d3x, or this 6d3 maybe?
Yeah, the derivative of 0 is 0. Derivative of 0 is another 0. Derivative of this one now is a 0 now. Because there's no x, it's a constant. So
okay.
Derivative of this one gives you 0 again. So what's the derivative of 6d3x?
6d3.
Okay, very good. What's the derivative of 12d4x squared?
24d4x.
24d4x. Perfect. So now how do I find out d3?
Well, when we plug in 0 for the x, we're going to have 6d3 equals 1, and when solving for that, we're going to have 1/6.
Yeah, d3 equals 1/6. So how do I find out d4?
We're just going to take the derivative again, which is going to be the 0 plus 0 plus 0 plus 0 plus 24d4.
Yeah, so the answer is going to be just 24d4 because all of the previous one becomes 0. So you got a 0 plus 0 plus 0 plus 0, just plus last one is 24d4. And this one equals?
1 over 24.
So it's 1, so you got a d4 equals 1 over 24. Very good. So now could you please tell me what my polynomial function is? What is the function?
I'm not too sure about this one.
So, the function, just plug it back into here. I got d0, I got d1, I got d2, I got d3, I got d4. So what is the p4x? So d1 is 1. Replace the d0 equals 1. Plug it in. So it's 1 plus d1 is what? 1, right?
Yep.
So plus what?
This x maybe?
Yeah. What's the continue? What's the d2x squared?
1/2 x squared?
Yes, from here it's half of x squared. What is d3x cubed?
1/6 x cubed.
Very good. What's the d4x4?
1/24 x to the power 4.
Yes, perfect. Okay, so very good. Okay, so now we got the function from the previous one. We got the d1. We got the function value. The polynomial function is p4x equals 1 plus x plus 1/2 x squared plus 1/6 x cubed plus 1/24 x power 4. So now I want to show you what the difference is. Okay. Why did I do that? graphing function. Okay, so now let's look at the graphing of some functions. So my polynomial first one is y equals e to power x, right? How do I type in e? Okay, very good. What is that? Okay. E to power x. This is my original function e to power x. Okay, so now my first approximation is y equals x. First polynomial I got is y equals, sorry, x plus is 1 plus x, right? The first one, 1 plus x. Okay, what is my second the second polynomial approximation? Can anyone tell me? 1 plus?
1 plus x, 1/2 x squared.
Plus 1 divided by 2. Then x square. Okay, that's the second approximation. Alright, so now what is the third polynomial approximation? Y equals 1 plus x plus 1 divided by 2 x square plus 1 over 6 x to the power 3, right? I'm gonna go 3. Alright, so let's look at the next one. What we got is 1, oh, that y equals 1 plus x plus 1 over 2 x square plus 1 over 6 x to the power 2 plus 1 over 24, right? 24 x power 5. No, x power 4. X squared 3, 4. Okay, so if we look at the picture, you can tell the red crimson, this one, you can see this one. You see this one? The color, you can match the color. This red color actually is red, right? The red color is e to power x, is the original function. The blue one is linear function 1 plus x. It's good, all of them is okay at this point. At this point it's good. But if you continue on the other point, the blue one is not really good. It has a really not big error. Yes? Now next one is a little bit better. See the green picture is a little bit closer. At least at some point it's close. It's very good. It's very close, right? The green one is getting closer to the red one. Now it's not even very good because at some point it has a big error again. What about the next one, the purple kind of? Okay, so it's going to be even closer. The third polynomial, you look at the picture, it's closer now. The best one now we can see is what? Is orange one. is very close to that original function y equals e to the power x. Okay, at least after 0 point is very, very close. Does it make sense, everyone? Yes?
Yep.
Okay, so from the picture you can tell that the higher polynomial you got, oh yeah, it did it right. So the higher polynomial you get, the closer it will be to the original function. That's the point of the polynomial, like Taylor approximation polynomial. Makes sense, right? Okay, so that's the idea from the picture. You can see first linear function, second degree, third degree, fourth degree. You can actually continue doing more. You can actually continue working on this. So I'm going to ask somebody to tell me, what do you think the P5x is? But I'm going to call someone to help me here. So Travis, what do you think the P5x is?
Be 62, 1 over 62.
No, you have a whole thing. The first is the same, right? So it's 1 plus x, right?
Oh yeah, 1 plus x plus 1 half x squared plus 1/6 x to the third plus 1/24 x to the fourth.
Yeah. What about the next one?
1 over 62 x to the fifth.
Okay. 120. Okay. How did you get at 120, Lacey? Multiply 24 by 5. Perfect. Yeah. You multiply 20 because it's fifth power. You got 5 times 4. So 5 times 4 times 3 times 2 times 1. When you take a derivative, it's kind of like you take the multiply the next number. So 24 times 5, you got this. That's perfect. And you can continue. P6x, you can see there is a continue. We have 1 plus x plus 1 over 2x squared plus 1 over 6x cubed plus 1 over 24 x4 plus 1 over 120 x power 5. Okay, so I'm going to ask another student here to help me. Nicholas, what do you think the next number is? 720. Okay, so x power what? 6. Perfect. Thank you very much. Okay, so if you continue, the P6x is going to be very, very close to the polynomial function. So then we can continue. Pnx, 1 plus x plus 1 over x squared plus, this is 3 factorial x cubed plus 1 over 4 factorial. Because you 4 times 3 times 2 times 1, you can use that as a factorial. And x4 plus 1 over 5 factorial x power 5 plus 1 over 6 factorial x power 6. I'm going to ask the student to tell me what is the nth term. Matthew, could you please tell me if I change this if this is n, is it 1 over what factorial?
Would it just be 1 over n factorial?
Perfect, okay. So it's going to be 1 of n factorial. If the n goes to limit, goes to infinity, n is very big, then the Pnx will be exactly the same thing as e to x. Okay. So we're going to have e to x equals n from 0 to infinity 1 over n factorial x to the power n. Okay. So this is the exponential function for, this is the polynomial Taylor expansion for the e to the power x. Okay. at 0. At x equals 0. Alright. Okay, so this is a complete example for the e power x. Let's look at a normally what do we have for any function. Okay. If it's not at x is not at 0 at another point, for example at c, we're going to have Pnx equals fc plus f prime of c x minus c plus f second derivative of c x minus c squared over 2 factorial plus fn at c over n factorial x minus c to power n. So this function, this polynomial, this one is called, that's just a general point, it's called nth Taylor polynomial for f at x equals c. Okay. If x equals 0, then I have Pn x equals f0, special case, f prime of 0 times just x, because x minus is just x, right? And plus second derivative at 0 times x squared over 2 factorial plus the third derivative at 0, 3 factorial x cubed plus, continue, plus fn 0 over n factorial times x power n. If it's if c equals 0, sorry, my bad. If c equals 0, not x equals 0. If c equals 0, so all the c equals 0 is a special case of this expansion. So this is another name for it. It's called nth. It's called nth Maclaurin polynomial for f. Okay, so these are the key point formula or theory for today. After we did so many examples, we get this formula. Okay. So let's look at example. Simple example. Find the nth polynomial center at c. Okay, for example, fx equals 2 over x and n equals 2, so second polynomial, and c equals 1. Find the second polynomial center at c equals 1. Fx equals 2 over x. I want to approximate this function at c equals 1. So, according to the Taylor polynomial formula, then we have P2 x equals, just a little bit smaller, then you can see that formula. So P2x equals f, center is 1, so it's f1 plus f prime of 1 times x minus 1 plus second derivative of 1 times x minus 1 squared. Okay. Now, f1, we can find it. f1, I'm gonna constant tell me what is f1. I'll call student here. Eric, could you please tell me what is F1? 2. Perfect. Okay. You just plug 1 into here. So I'm going to call another student to tell me what is the first derivative f prime of 1. I'll give you 5 seconds to work on it. So what is f prime of 1? I will call another student here. Joshua, can you tell me what is f prime of 1? Negative 2. Very good. Okay. F prime of x, you can do that, is a derivative 2 times x to negative 1. Because this 2 over x is 2 times x to negative 1, you take the derivative is negative 2 to x to negative 2. Then you plug 1 into here is negative 2 times 1 to negative 2. You know that is going to be negative 2. Okay. So f prime of 1 equals negative 2. Okay, so I need to find f second derivative at 1. Okay, so Lisa got an answer is 4. Perfect. Okay, so basically you take the second derivative and you take the derivative on this one again, negative 2 to x negative 2 derivative, and you multiply by negative 2, so it's negative 2 times negative 2 times x negative 3 power, right? And the negative power reduced by 1, and then it's 4 times x to negative 3. Plug 1 into here, so it's 4. I'm down here, so once I got f1, f prime of 1, f prime of 1, so I got my p2x equals 2, f1 is 2 plus prime of 1 is negative 2, right? So it's minus 2 x minus 1 plus, finally that it's 4. Just replace that value again. And then I got my second degree polynomial. I'm done. Does that make sense, everyone? Yes. Once you find the polynomial, once you use it's the whole thing we got. I just want to help you to understand how I got the formula, the polynomial formula. Once you notate the polynomial formula, it's pretty simple. You just find the first derivative, second derivative, it's done. Just that simple. Okay. All right. So we're going to continue this section tomorrow and look at more examples, and I'll practice more, and I'll also assign homework to do the polynomial function as well. Okay. I'll let you practice. So if you have any questions, just let me know, and we're good for today. Thank you very much for coming. I'll upload the video online too.